So in the previous two lectures, we talked about the step-by-step implementation of simplex algorithm. In this lecture, we are going to solve an example of using simplex algorithm for linear optimization. All right. So the question is minimizing minus 3x1 minus x2 minus 3x3 subject to 2x1 plus x2 plus x3 less than or equal to 2, x1 plus 2x2 plus 3x3 less than or equal to 5, x1, x2, and x3 are all positive. So the first step that we have to do here is to transform the inequality constraints. Step 1, inequality constraints to equality, because we want to have the standard form before starting the simplex method. So what I'm going to do, I'm going to add slack variables x4 here and x5 here. So what will happen now? We have x1, x2, and x3 as our variable. Then we will have minimizing x1, x2, x3, x4, and x5. And another thing to consider is the coefficient for x4 and x5 in the objective function are 0. Minus 3x1 minus x2 minus 3x3. Subject to 2x1 plus x2 plus x3 plus x4, which is the slack variable, is equal to 2. And x1 plus 2x2 plus 3x3 plus x5 is equal to 5. x1, x2, x3, x4, and x5 are all positive. So what we did, we transformed these inequality constraints into equality constraints using the slack variables. So what is the starting point? What's one of the trivial answers to this problem? Usually when we transform inequality constraints into equality constraint, one trivial answer is to have slack variables as the base variable. What's the reason for this? Because these are the number of slack variables here is the same as the number of constraints. So if you recall, number of basic variables is equal to number of constraints, right? So in this case, we have two basic variables. I'm going to choose x4 and x5 to be my basic variables, and x1, x2, x3 as non-basic variables. So if you insert values of x1 to x3 to 0, what will happen? It gives us the value of x4 and x5. So x1, x2, x3 are 0, non-basic. x4 is equal to 2 based on the first constraint, and x5 is equal to 5 based on the second constraint, basic variables. So I'm going to rewrite our optimization problem considering all this. So it's going to be minimizing 0, 0, x4 and x5 because they don't appear in the objective function, plus minus 3, minus 1, minus 3, x1, x2, x3, subject to. Now we want to write it in the standard format. So we have x4, x5 plus 2, 1, 1, 1, 2, 3, x1, x2, x3 is equal to 2, 5. All right. How did we determine all these? These are based on the coefficients that we have here. So 2, 1, 1, 2, 1, 1, 1, 2, 3, 1, 2, 3. We have 2 and 5 here. And the same for x4 and x5, their coefficients are 1. So now we want to find the elements that we need to create the tableau. So this is CB, or the coefficients of the basic variables in the objective function. This is CD, or coefficients of non-basic variables in the objective function. This is the base variable coefficient, base variables. This is D, or the coefficients for non-basic variables, and finally this is B. Based on these, we are going to create the tableau. So for the tableau, if you recall, we had the base x's here. Here our x bases are x4 and x5. Then we had the non-basic. For the non-basic, we have x1, x2, and x3. And then we had the others. So I'm going to write the identity matrix here. And then these coefficients for the non-basic variables. And then the right-hand side vector. The value of our objective function at this point is 0. So when we choose negative 0 is again 0. What's the reason for this? Because if you insert these initial values in the objective function, it's going to be 0. What's our objective? It's a combination of x1, x2, x3. And now all of them are 0. So the objective function's value is also 0. Then here we have 0 and 0 as the coefficients in objective function. So 0, 0, 0, 0, 0 for the basic variables, and -3, -1, -3 for the non-basic variables. All right, let's start with this tableau and see how we can do the steps of simplex algorithm. The very first step is to identify the column. So we have 3 non-basic columns. Which of these columns can we choose to start the process? So we said we start with the column with the most negative value. But here we have 2 columns with the same negative value, and both of them are the most negative. So we can start with either of them. What I'm going to do, I'm going to choose this column and see what will happen in the next step. So I'm going to rewrite this again. So we have x4, x5, x1, x2, x3, 1, 0, 0, 1, 0, 0, 2, 1, -3, 1, 2, -1, 1, 3, -3, 2, 5, 0. All right. So after deciding which column we want to use, what we are going to do, we are going to divide these values by the corresponding coefficient of that column. So 2 divided by 2 is equal to 1, and 5 divided by 1 is equal to 5. All right. Now we have to choose which row we want to deal with, which row we want to switch the non-basic and basic variable. So we said the smallest positive value among these two. So 1 is the smallest positive value. So this is I, this is J. All right. So now we want to see which of the basic variables are 1 at this row. This is x4. x4 is effective in this constraint. So what we have to do, we have to switch x4 and x1. But in order to do that, first we have to make sure that the column corresponding to x1 is exactly similar to what we have for x4 now. What does that mean? So 2 should be 1 and 1 should be 0. So in order to do that, we are going to do some linear combination of rows and columns. So if you want to do that, then first we have to divide this by 2, which is going to be, let me rewrite this table so you can see. So we have x4, x5, x1, x2, x3, 1, 0, 0, 0, 1, 0, 2, 1, minus 3, 1, 2, minus 1, 1, 3, minus 3, 2, 5, 0. So what I'm going to do, I'm going to divide this row by 2 because we want to make this 0, 0, 1, 0. And then what I'm going to do, I'm going to subtract the first row from the second row. So now this is 0.5, 0, 1, 0.5, 0.5, 1. Now I'm going to, let's call this row 1, row 2. I'm going to subtract row 1 from row 2. What does that mean? Minus 0.5, minus 0, minus 1, minus 0.5, minus 0.5, and minus 1. So what it does, it's going to transform our tableau into x4, x5, x1, x2, x3, and then the right hand. So we have 0.5, 0, 1, 0.5, 0.5, 1, minus 0.5, 1, 0, 1.5, 2.5, 4, and 0, 0, 1.5, 0.5, minus 1.5, 3. Oops, sorry. This one is going to be, yeah, we also have to remove R3 plus 3 R1. So we also have to add 3 times of the first row to the last row. Why? Because this should be 0. So this is 3 minus 3, 3 multiplied by 0.5, 1.5 minus 1, which is 0.5, and 3 multiplied by 0.5 minus 1.5. And what will happen here? 3 multiplied by 0.5, which is 1.5. This one is going to remain 0. So we have 1.5 here and 0 here. So now x1's column is ready to be switched with x4. That's how one of our non-basics enter the basic and one of our basics enter the non-basic. I'm going to switch these 2 columns and rewrite the tableau again. So let's see how our new tableau looks like. x4, x2, x3, 1, 0, 0, 0, 1, 0. If you notice here, the x basis is still the same format as before. What does that mean? That means there is an identity matrix and the coefficients here are 0. And then we have the rest of the tableau. So we use some linear combinations of rows to make sure that the column that wants to enter the basic has exactly the format that we want, 1, 0, 0. 5.5 minus 1.5. the updated value of our objective function. That's something that I should have mentioned here. Yeah, so 3 multiplied by 1 is going to be here, which is 3. All right, so this value shows the negative of our objective function. So our objective function so far is -3. Now again, we look at the relative cost vector, and what we observe is there is still some negative elements. So if you recall from the different steps of simplex algorithm, this means that we still need to continue doing the simplex algorithm rotations. So what I'm going to do, this time we only have one negative column, so x sub 3 is our choice. But how about the column? We have to divide 1 and 4 by these two values. So 1 divided by 0.5 is 2, and 4 divided by 2.5 is 1.6. So we have to choose the smallest positive value. This is the smallest positive value. Each of the basic variables this corresponds to, this is 2.5. All right. So which of the basic variables this corresponds to? We come here, x5. So at this step, we want to switch S5 and x3. Again, we are going to do some linear combination of rows to make sure that the column corresponds to x3 is exactly similar to what is x5 now. So we want to transform x3's column to 0, 1, 0. If we do this using linear combination of rows, what will happen? We are going to have x1, x5, x4, x2, x3. So x1 is still the same, so it doesn't change. x5 is going to be minus 0.2, 0.4, and 0.6. x4, 0.6, minus 0.2, 1.2, x2, 0.2, 0.6, and 1.4. And x3 actually is going to be ready to move to the base, to the basic variables. All right, so at this point, I'm going to switch. What does that mean? Non-basic x3 replaces x5, which is the basis. So how does our new tableau look like? Our new tableau looks like x1, x3, x4, x2, x5, 1, 0, 0, 1, 0, 0, which is the standard format for the basics, 0.6, 0.2, minus 0.2, 0.2, minus 0.2, 0.6, 0.4, and 1.6, 5.4, 1.2, 1.4, 0.6. All right. Now that we have this tableau, we have to look at the relative cost vectors again. As you can see, all of them are positive. So we reached the optimal solution. And the question is, what are the values and what are the basic variables? So the only non-zero answers are basic variables. x1 is equal to 0.2, x3 is equal to 1.6, and the rest of variables are 0. And this tells us the negative value of our objective function. Let's try to evaluate this. So as I said, 1, 0, 0, 1 multiplied by x1, x3 is equal to 0.2, 1.6. What does that mean? x1 is 0.2, x3 is 1.6, It also tells us that x2 is 0, x4 0, and x5 0. Also, if you look at the tableau, what you see, negative value of our objective function is 5.4, which means the optimal value of objective function is minus 5.4. Now let's look at the original objective function. The original objective function was minimizing minus 3x1 minus x2 minus 3x3. So minus 3 multiplied by x1, which is 0.2, minus x2, which is 0, minus 3 multiplied by x3, which is 1.6, minus 0.6, minus 4.8, which is minus 5.4. As you can see, the answer is the minimal answer. So I'm going to show the big picture of this for you just as a reference. So if you want to write it down and practice yourself, you can refer to that. So this is our problem. And then, let's see. And then we wrote it in the standard format using x4 and x5. In the next step, what we did, we tried to extract the basic and non-basic variables. Then we created the standard tableau. First step, we determined which column and which row. Then we switch these two. At the next stage, again, we determined which column and which row. We switch these two as well. And finally, this is minus optimal value of your objective function, and this is your final answer. So this is the example that I wanted to discuss today. That's all for this lecture.